Alright, let's solve the rational inequality. 3x minus 8 over 2x minus 1 is greater than x minus 4 over x plus 1. The easiest way to do this is I'm going to move all of my terms to one side and let the other side equal 0. So I'm going to take x minus 4 over x plus 1 and move it to the other side. So now I'm going to get 3x minus 8 over 2x minus 1 minus x minus 4 over x plus 1 is greater than 0. Now the next thing you want to do here is you want to find a lowest common denominator, right? Because you're subtracting, they're basically fractions, these are two rational functions, rational expressions, and you want to change and make them a common denominator. So the lowest common denominator here is 2x minus 1 times x plus 1, right? So what I'm going to do here is I'm going to change 3x minus 8 over 2x minus 1 to have that common denominator by multiplying x plus 1, and you get 3x minus 8 times x plus 1 over 2x minus 1 times x plus 1. Okay, so now you have the common denominator. Right, you can simplify the numerator by expanding it. So I'm going to expand 3x minus 8 times x plus 1. If I expand this, I'm going to use the FOL method. You get 3x squared plus 3x minus 8x minus 8. Right, and then collect the like terms, so you get 3x squared minus 5x minus 8. Okay, so that's the numerator. We also want to do the same thing for x minus 4, right? So I'm going to multiply this guy by 2x minus 1, right? And I'm going to do the same thing for the denominator. So now you get x minus 4 times 2x minus 1 over x plus 1, 2x minus 1. Then if I expand the numerator, I'm just going to look at the numerator by itself. If I expand the numerator, you get 2x squared minus x minus 8x plus 4, which is 2x squared minus 9x plus 4. Okay, so this guy here is over 2x minus 1, x plus 1, and I'm going to subtract this by negative 2x squared minus 9x plus 4 over 2x minus 1, x plus 1. I'm going to just make a collective numerator. I'm just going to do that in blue here. Okay, so this is our collective numerator now. So we have 3x squared minus 5x minus 8 minus 2x squared. So you're going to apply the negative to all the terms here. Right, so minus 2x squared plus 9x minus 4. Okay, and then this is over the collective denominator 2x minus 1 and x plus 1. Just off the bat, you can write down the restrictions here. Right, the restrictions, x cannot equal 1/2, because then this would be 0 or negative 1. Okay, so just mention those restrictions really quickly. And this is what our combined, so let's simplify our combined rational expression. In this case, we get 3x squared minus 2x squared, that's x squared, minus 5x plus 9x, right, that's 4x. Minus 8 minus 4 is minus 12, and then this is over 2x minus 1, x plus 1. Now, remember, this is an inequality, so I'm going to make this was initially greater than 0, right? So basically, this guy here is my new simplified rational function. I'll call it r of x, and I want to find when r of x is greater than 0, okay? Now, we can actually factor the numerator out, right? So two numbers that add up to 4 that multiply negative 12, so x plus 6 times x minus 2 would work, right? And this is over 2x minus 1 times x plus 1 is greater than 0. Now at this point, what you need to do, after you've simplified and you factored this out, you need to find critical numbers. Now your critical numbers include x-intercepts and your vertical asymptotes, or restrictions on x. Now we wrote down the restrictions on x, it's 1/2 negative 1. So these are our critical numbers C, 1/2 negative 1. These are non-inclusive points. We also have our x-intercepts, where we let the numerator equal 0, so that's going to include negative 6 and 2. So we also have negative 6 and 2, right? Those are our critical numbers. We take our critical numbers and we plot them on a number line in order to find our intervals, right? That's what the critical numbers are used for, to find our intervals. So now we have negative 6, negative 1, positive 1/2, and we have positive 2. And all of these points are non-inclusive. The vertical asymptotes are non-inclusive by default, but because it's greater than 0, it's not equal to 0, then it can't be inclusive of the x-intercepts, right? So this point here, this interval here is negative infinity and negative 6. This interval here is negative 6 and negative 1. This interval here is negative 1 and 1/2. And this interval here is 1/2 and 2. And this interval here is 2 and positive infinity. Okay, so those are our intervals. We have 5 intervals. Now what we're going to do here is we're going to create a table of intervals to solve for our intervals. Okay, so I'm going to do that there. Okay, so x belongs to, I'm going to put my factors out here. Okay, so my factors include x plus 6, x minus 2, right, 1 over 2x minus 1, 1 over x plus 1, and also my collective rational expression r of x. Okay, so I'm going to write my intervals up top, so negative infinity, negative 6, negative 6 and negative 1, negative 1 and 1/2, 1/2 and 2, 2, and positive infinity. Okay, so now that I have all of my intervals, then I'm going to plug them into this function. Let's say x is equal to negative 7, right? So then this is negative, negative, negative. Okay, so this would be positive, so this would be greater than 0, which is essentially what we're looking for, because this is basically our expression, right? So this is one of our solutions, right? So this is one of our solutions. Between this interval, negative 6 and negative 1, x is equal to, let's plug in negative 2, that falls in between this interval. We have positive, negative, negative 2 times 2 is negative 4 minus 1 is negative 5, negative 2 times, negative 2 plus 1 is negative. So then this is going to give us negative, so this is less than 0. Between this interval, x is equal to 0, so you get positive, negative, negative, positive, so this is positive, greater than 0. So this is another one of our solutions. Between this interval, x is equal to 1, positive, negative, positive, positive. This is negative, so this is less than 0. Between this interval, x is equal to 3, so we have positive, 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 positive. So this whole thing is positive and it's greater than 0. So this is another one of our solutions. So therefore, to solve this inequality, x belongs to negative infinity and negative 6 union negative 1 and 1/2 union 2 and positive infinity. Okay, so all of these terms, all of these values in these intervals will satisfy this following inequality.